Good afternoon, ladies and gentlemen. Welcome to Architects Fast Forward webinar series. My name is Lillian, and I will be your moderator for today. Architects Fast Forward is a webinar series focused on the holistic perspective from the industry. Each session brings together collaboration from the industry with renowned architecture and building professionals, sharing their experiences from various perspectives, including industry, business, and education, to address current key issues and topics. Please note that this session is CPD applicable. To claim your CPD points, please follow the instructions in the comment section. Today's webinar is themed Common Site Issues Relating to Tile and Stoneworks by MAPE. Tile, marble, granite, and natural stones are common finishes used in residential, hospitality, and commercial buildings. Installations are on interior and exterior of buildings, walls, and floors. As much as everyone looks forward to a good quality and durable installation, it is possible that there will be times when some installations might end up with various unfavorable site situations. This session will review some of the common issues and complaints, as well as discuss possible causes and solutions on how some of these issues can be avoided and resolved. This session's speaker is Ms. Jesseline Yap, Senior Manager of Adhesive Line, MAPE Far East Private Limited, Singapore. Jesseline has more than 25 years of sales and field experience in tile and stone fixing materials and related works in the construction industry. Trained by industry leaders in Italy and the US, Jesseline is well-versed with product and technical knowledge as well as application for tile and stone installations. Without further ado, we shall hand over the session to MAPE.
Hi, good afternoon. My name is Jesseline, and I'm going to be sharing with you the topic on common site issues relating to tile and stonework, and we'll discuss on the possible causes and solutions. MAPE Singapore and MAPE Malaysia are part of the MAPE group, a bigger MAPE group based in Europe. To date, we have 90 subsidiaries with 83 production facilities across 5 continents. Founded in 1937, MAPE was founded in Milan, Italy, and today we are the largest producer of adhesives worldwide for ceramic tiles and stone materials. Okay, so today's topic is on common site issues, and one of the issues that we'll talk about will be on deboning of tile and stone. For deboning, there are different scenarios, okay? So we'll cover some of them. And one of them you might have come across will be on tile buckling. Okay, if you see this picture, the tiles have actually buckled up, all right? And again, if you have come across a situation like this, for your rectification, when you try to cut open the tiles and you try to place it back into the space, it will no longer fit into the space, all right? Generally, when that happens, something has changed. Okay, so for this situation to occur, it normally originates from a state of compression in the tile surface parallel to the plane of the surface. And this, it's because the tile is compressing one against the other, then creating the tension in the interface between the tile and the adhesive bed. Okay, so of course, when it happens, then you have to do corrective measures. So you have to cut open and then fix it back. And because the tiles do not fit into the size anymore, you probably have to size down your tile in order to accommodate the new tile installation. But a preventive measure will be helpful, and that is where you can work on the design, okay? And to prevent such a situation from happening, ideally, you allow a bigger joint width, okay? Depending on the tile types that you have selected, because tiles, there are press tiles, which like the homogeneous tiles are produced by the press method. And then we have the extruded tiles like the clinker tiles, quarry tiles. that are produced by the extrusion method. And the tiles that are produced by the different methods, they do have what we call manufacturing tolerance. So you need to find out what is the manufacturing tolerance and provide a joint that is bigger than the manufacturing tolerance. Okay, so the concept is to provide a wider joint so that if there's any expansion in the tile or shrinkage in the substrate, a wider joint allows that movement to take place. But of course, at the same time, you need to have a flexible adhesive that can accommodate the stress and allow that movement also to take place. And if you're tiling over a big tiling area, like external floors or over a big tiling span, then you need to incorporate movement joints at the appropriate intervals. Okay, so this can be prevented early in the design stage. So sometimes expansion can occur because of thermal variations. Okay, so if you look at the picture here of an installation that has experienced some problems, you'll notice the picture on the right, the stones have actually bounced out of its original position, and so you can actually see cracks. Okay, and this is probably due to the installation. You look at it, there are no joints, so it seems like they incorporated butt joints, right? So butt joints do not allow that space to move, so cannot accommodate that thermal variation. So if you look at this wall, during the design stage, all right, besides allowing a wider joint width to accommodate the stress, because you look at this wall, it's facing the sun, hot sun, afternoon sun, okay, almost every day in the year, okay. So if the wall is so large, so long, maybe it can break into two movement joints, okay, two vertical joints, movement joints with a soft sealant, and then in between the stones, yeah, have a wider joint width, okay. So avoid butt joints, right? We generally do not recommend butt joints. Okay, butt joints, you might have this problem of breakages due to differential movement. This stone application is the internal application, internal wall. If you look at this breakage, it's actually happening at the edges. And if you look at it, actually there are no joints. All right. So it can be a situation whereby there's this differential movement taking place and the stones are butting against one another. So you have this friction that causes the edges to have breakages. Okay. And when this happens, yeah, you know, it's difficult to repair the stone again, all right? So when you try to touch up the stone, it doesn't look as good as the original, all right? So to prevent this from happening, it's good to allow a wider gap between your stones, all right? Because also, you know, some stones do not come in exact sizes, so you have what we call cutting precision accuracy. So you need to also allow for some of this tolerance, okay? So avoid butt joints, all right? Also, butt joints when you're doing tile work, when the joints are so narrow, it's difficult to fill the joint with the grout. Okay, so when the joints are unable to be grouted properly, it's not your grout mortar is unable to fill and compact it into the full depth of the tile thickness, your application actually is very shallow. And if it's shallow, under stress or under impact, under load, the grout comes off easily. And when that happens, yeah, the joint is open for contamination. Okay, so it's good to allow a wider joint width so that you can also fill the joint with grout material properly. So as mentioned, in a very big tiling area, if you have a big tiling stand, you need to provide movement joints. Okay, so there are some guidelines given where there are certain intervals that are recommended joint width. Okay, this interval spacing is taken from our Singapore standard CP68. So they do have some guidelines: internal walls, internal floors, and then internal can be areas that are exposed to the sun. All right, so if you have a lot of sunshine coming in, then you also need to allow more space, yeah, you know, more intervals. External every 3 meters, a 10 mm width, or a 5 meter interval, 12 mm. Okay, it's good to provide more, but try not to stretch your intervals. Okay, try to give a more provision in terms of safety margin. Okay, because when there's stress accumulated, you want to allow that stress to be released as early as possible, so that you may not, you know, end up with a tile popping up situation or buckling situation. Of course, when we talk about thermal variation, your tile color, stone color does also have an impact, because darker stone colors or darker tile colors absorb more heat. So you may have more expansion in those situations. Yeah, so you take in consideration those situations and you make the necessary provision. Okay. So for movement joints, normally it is a sealant. So sealant products, you have silicone sealants, you have polyurethane sealants. Okay, and all sealant products have what we call the extension capability. So some sealants have more expansion capability. Okay, we say the silicones have 25% expansion capability. So means to say that if your joint width is 10 mm, a 25% capability means it allows an expansion of 2.5 mm. Okay, yeah, silicones, of course, because it's a silicone, show hardness is lower. So generally we use them for wall. But if you want to use it for floor, we normally try to confine it to a smaller width. Okay, if you have a bigger joint width on the floor, then typically we will use a polyurethane sealant that has got better show hardness. Okay, so the expansion capability for internal, where you have less expansion or less thermal variation, you can go for a lower percentage. For external, try to go for a higher percentages like 20% or 25% expansion capability. Okay, so it's all part and parcel of the tile work. All right, there are some guidelines that you can refer to, whether it's CP68, TCA handbook, or even the British standards that gives you some information on interval span and where are the locations to put the movement joints. Okay, so in tile work, it is one of the necessary detailing if you have a big tiling area. Another common site situation you may experience will be hollowness and weak adhesion. Sometimes weak adhesion can result in debonding. All right. So if you look at this installation, okay, if you look at these tiles on the inside, they look all right. But in actual fact, when we remove one piece of it, we notice that there's a lot of voids. Okay, the adhesive application is very thick. All right, so much so that when you look at this, there's a lot of voids, and all these lines that are created using a notch trowel, they have not collapsed. Okay, meaning to say that the worker probably did not press in the towel enough to make sure that the trowel lines collapse and that the adhesive is well compacted. Okay, so one reason he doesn't do it is because maybe one of the reasons will be alignment. Okay, he's trying to catch the alignment on the wall, so he will not want to push it all the way in. All right, so this is same picture here shows you the example. If I were to remove all the adhesive and reapply again and press in the towel fully until it's well compacted, you see the level difference. Okay, so this level difference prior to the tiling commencement, by right, the substrate tolerance needs to be corrected. Okay, correct it so that it is plumb and true. And then when you apply the adhesive and fix your tile and press it down fully compacted, yeah, you actually get a very well compacted adhesive layer. Okay, a good tile installation. Okay, so normally when you have hollow spots, sometimes it could be from all these air voids. And situation like this, okay, I'm not sure if it's something that you have come across. Okay, the problem here is that we see two layers of adhesive which are not well compacted. All right, so how did we actually arrive at these two layers of adhesive? The first layer is the notch trowel layer, whereby the worker may have used the notch trowel to apply the adhesive onto the substrate. Okay, the outer layer is probably the layer that he applies on the back of the tile or the stone. Okay, so when he covers the adhesive with the stone, by right, these two layers must be compacted to become one layer. Okay, this two layer, when you press down, it should become one layer. All right, so make sure that when the worker installs the tile or the stone, yeah, sometimes we at random we have to pry open one piece to see what's the overall wetting out adhesive. We must see the two layers collapse and flatten into one compacted layer. We should not see two layers like this. All right. If you see two layers like this, chances are the stone or the tile is hanging on the outer layer, which is sitting on the inside layer. So the grip is actually quite weak. All right. So sometimes this happens again because substrate not accurate. So sometimes workers will not want to push in your stone or your tile, okay? Because when he pushes in, your adhesive layer is going to thin down a little bit, which is supposed to be the case. But when it flattened and compacted, then he may not catch the alignment. So the alignment issue is always the substrate accuracy issue, all right? Sometimes when the stone falls off, you see this situation, you say, oh, there's a lot of adhesive, it's fully beaded, full of adhesive, so it shouldn't be the problem, okay? But if you look closely enough, you actually see all these clues, which is an indication that there are two layers, which is like what we saw in the earlier slide, okay? Yeah, you actually see two layers of adhesive. So we must not see two layers of adhesive. So same thing for this, you will actually see two layers. It's a similar situation as the earlier one. You see a notch layer and you see the outer layer. All right. So in this drawing, I'm trying to simulate for you to see what is like. This is a substrate, and this is the notch layer, which is the inside layer. And the outer layer, which is applied onto the back of the tile or the stone, is being pressed into this layer. But you see, it's sitting on the trowel ribs, all right, which is actually quite weak. So to us, this is the weakest link, okay, where the two layers meet. So for a good grip, the two layers must be compressed into one compacted layer. All right, just to show you. So when we have this towel ribs, they're supposed to press down the towel. Of course, if the tiles are small, it's easy to press down. When the tiles are big, you probably have to do a little bit of massaging, slide it to the left, to the right, up and down, so that this towel ribs can collapse. So the initial application thickness can be like this, all right? But after they press down the towel into the base, into the substrate, the compacted layer should be like this, okay? And generally, in terms of the thickness, the final thickness is normally about half of the initial applied thickness, okay? This layer of the trowel rib has to collapse. So when the mountain and the valley is collapsed into one compacted layer, you generally will get about half the thickness of the initial applied thickness, okay? Another situation that we come across on site will be maybe open time issue. Okay, then you ask what is open time? Open time actually refers to the interval time of the spread. As you spread the adhesive with a trowel, then it will be quite a while before you fix the towel over, right? So the interval time where you cover with a towel, okay, the adhesive is exposed to the air environment. So there is an open time situation, all right? Most adhesives will give you an open time of 20 minutes. Okay, and if you have an extended open time material, it's probably 30 minutes. But the point to take note is that the worker should apply the adhesive onto the substrate and quickly cover with the towel as soon as possible within the open time of adhesives. Regardless of brand, all adhesives have this characteristic of open time. Okay, it's a default situation because of the polymers that are added into the cementitious product. Okay, so when open time has lapsed, how will you know? Your fingers can do the test, all right? A skin would have formed on the surface of the adhesive, invisible skin, and how to detect it, use your fingers. When you tip your finger onto the layer of adhesive, if it's no longer sticky, and what you do is you leave a fingerprint on the surface, it is an indication that open time has lapsed, okay? What's the solution? If you have a fingerprint and you touch this layer, it's still soft, but it is no longer tacky. Remove, okay? You can actually use your notch trowel to scratch the layer to break the skin. So we say re-notch it, okay? But after re-notching it, if the material still looks good, still soft and tacky, that's fine because open time may have lapsed for maybe a minute, about a minute, so it's okay. But sometimes if the worker applies the material over a big area and open time has lapsed for quite a while, and when you try to re-notch it, you start to see creases here and there, or the adhesive is about to break up. All right, then you should remove totally and reapply. Okay, so your fingers can do the test because to know that the adhesive still has got good open time, when you dip your finger, it is still tacky. Okay, but of course, we want to prevent that. Then to cut down wastage, to cut down situation where workers may have tiled over a skin layer, prevention will be control the spread. Okay, it is always good to control the spread. So if you're working with smaller tiles, say 300 by 300, then the tiler should try to spread the material within an arm's length and quickly cover with the towel. So we say try not to spread beyond 1 square meter. So if you cannot measure, then use his arm as a gauge within an arm's length. If you're using 600 by 300 by 600, then maybe not more than 4 pieces at one go. All right. So control the spread and quickly cover, control and cover. Yeah. So you do your finger test. Okay. But again, when you have very big tiles, say tiles are 1.2 meter, so you have to spread as big as 1.2 meter on the surface as well as on the back of the tile. Then what we say is that you choose an adhesive that has got this property of extended open time. Okay, so more than the normal 20 minutes, extended open time gives you a working time of about 30 minutes or more. Okay, so if you have bigger tiles, then choose a product that has got extended open time property. Then sometimes problem can also occur when your adhesive applied too thin, okay, insufficient contact, insufficient coverage. You can actually tell after randomly opening a piece or two, you will notice that you have a lot of spaces here. So it's an indication that there's not enough adhesive, okay? So he has to apply more, all right? Sometimes when you're working with mosaics which has got recesses on the back, you notice this recesses? Yeah. So when they apply just enough for this layer, but not enough to cover the recess, then your application is only 50% contact. Okay, so you have to be careful with towel back. Generally, when we realize that your application is insufficient, or rather using a wrong notch, then the correction is use a bigger notch. You size up another level. Okay, all steel notch trowels come in these sizes. So if the notch size that you use is gives you insufficient thickness, then you have to change to a bigger size to increase the thickness. Okay, and you will notch on the substrate as well as the back of the towel. Okay, so for prevention, ensure that you're using the appropriate notch. Sometimes there are some guidelines. So for example, say if you're doing 300 by 300, an average adhesive thickness is about 5-6 mm. Okay, if your substrate is accurate, less than 3 mm tolerance. Then to get a 5 mm, you get a notch size that can give you a 5 mm final bit. So normally a 5 mm, we will use a 10 mm notch. Okay, and then when you press down, you get a 5 mm. All right. For 300 by 600, sometimes we use also a number 10 notch, or we might use a KF notch. Okay. So generally, we determine what is your adhesive thickness that you need to achieve as your final, and then you choose a notch size that can help you to achieve that final thickness. Okay. So using appropriate notch trowel is important. And then for towels with towel back with recesses, you need to fill the gaps. All right. If not, then what is going to happen is a lot of the gaps here are all hollow. All right. So your contact is only 50%. So your strength, you're getting 50% of the adhesive that you have chosen because the contact is only 50%. Okay. Then make sure that when the tiles are pressed in, it is pressed firmly into the adhesive bed, against the substrate until the adhesive is well compacted. Sometimes the worker applies a lot of material, okay, like in the buttering method. But the problem is the adhesive is not in contact with the substrate. All right, you notice when they do buttering method, you see all these gaps. Yeah, they will scrape off to make a recess. So that the idea is when you push the stone in, all this adhesive is supposed to spread out. Okay, but unfortunately, it does not spread out that easily. Okay, because the application is very thick, and normally when they apply very thick, the mix is a little bit dry. So it's hard to spread out. We say it's hard to wet out the adhesive. All right. So this method of laying using back buttering might cause this situation. Yeah. So all these recessed areas may not touch the substrate, as you can see from here. Okay. All these gaps here, they are not touching the substrate. All these recessed parts, it is not touching the substrate. So we do not know exactly how much of the application is touching the surface of the substrate. Okay, so if 50%, you get 50% bond. Yeah, so this is application. So we generally do not encourage full back buttering method. Okay, so one solution will be, as in the earlier slides, use the notch trowel method. Okay, apply the adhesive with the notch trowel, and then apply a thin coat onto the back of the stone or the towel. And when you cover with the towel, you must press it in. Okay, it's important to press in to make sure that the two layers become one layer to a well compacted layer. This is very vital for towel work. Towel work using the adhesive by the notch trowel method. Okay, when the tiles or stones are large, then sometimes the transference of the human weight to press down may not be so easy. Yeah, so that's where you have to do a little bit of massaging, left to the right, up and down. The whole idea is to allow the adhesive to spread out. okay, spread out to cover the entire back of the tile or the stone, okay. So generally, when workers apply very thick, normally the indication is that your substrate is not flat or not accurate. Okay, so in most tiling works, if you read some guidelines given, even in CCNA, for adhesives, or rather for tile installation by the thin bed method or the adhesive method, substrate tolerance has to be plumb and true. Okay, so generally the given will be 3 mm in 3 meters, or if you consider it's 3 mm in 2 meters. Okay, your tolerance in your substrate should not be more than 3 mm. So if you have a 3 plus 3, your application thickness is probably about 6 mm only. Okay, or 3 plus 4 mm is about 7, or 3 plus 5 is about 8. But it shouldn't, by right, it shouldn't go more than that. Okay, if it has to go more than that, then chances are the substrate is not accurate. Okay, and we avoid buttering thick layers like what you see here. Okay, when it's very thick, chances are it's hard to wet out, and then all these recessed areas will not touch your substrate. Okay, an important thing is you need to press in your tile fully until the adhesive spreads out and has full contact to the substrate, full contact to the back of the tile. Okay. Then sometimes we have debonding when we have marble with backnetting or even tiles with backnetting. Okay, so we cover marbles first. You can see from this picture, the marble actually comes with a net and there's this coating supplied to the contractor as it is. And when the stones fell off from the wall and we go in and take a look again, and we realize that this is the adhesive, this is the net, and this layer is actually part of the stone. It comes with the stone. All right, which means to say that the integrity between this netting and its binder and the back of the marble is in question. All right, and this layer is cannot be controlled by the contractor, cannot be controlled by the adhesive supplier, because the adhesive is not in contact with the stone at all. So the break-off layer actually is this layer from the stone. Okay, probably at the factory. So again, when they supply you with the stones, with this coating, we really do not know what was the material used, whether it is a strong material, whether this layer will break off one day, which in this case it has broken off from the stone. Okay. Then sometimes, okay, we know that sometimes these stones come with the backnetting, and by default it comes with the backnetting. But how did the backnetting come about? Chances are when they ship from overseas, to prevent breakages, they put a netting to stabilize the stone. Then when the factory and then when ship to Singapore or even ship to Malaysia, then they cut the stones and it comes with a net. All right. Ideally, stones should not have the net. But if it comes to the net, then we will need to address the issue. Okay. So on the wall, we worry about this layer. On the floor, you might experience hollowness, which may not be a safety issue, but you may experience hollow situations. Yeah. So we take a look at this. They remove the net. So the contractor knows that he shouldn't use the net, so he removed the net. But unfortunately, there's still this layer of his glue. Okay, because the net is bonded to the back of the stone with the glue. Okay, and you see the stone is black, but actually this whitish thing is the glue. All right, you can see from here. Yeah, if you don't look at this part, now just look at this part, you think that it's okay. All right, but in actual fact, there is a very thin layer of the glue residue which can be removed. All right. So assuming that this is not removed, and if this layer were to dissolve, it will be the bond breaker. Okay, it will be the bond breaker because the stone that will debond first will be this layer before the adhesive breaks down. All right. So it's always this layer. So be careful when you remove the back netting. Pay attention to the glue residue. Okay. So after remove the netting, always check for the glue residue. One way is, put some water, rub it, and then see whether the water will turn sticky. All right. If the water can turn sticky, then chances are this presence of the glue. All right. But of course, you want to play safe. You can also grind the back of the stone. The idea is to remove that residue, the glue residue, which is harmful. All right. Also, mosaic sometimes they come with backnetting. We prefer to use face paper mounted mosaics so that the back of the mosaic is in direct contact with the adhesive and is able to press into the substrate. But in situations like this, where there's a pattern, then of course it comes with this back netting. But if you look at the netting, it's fully netted such that the adhesive will not be able to penetrate through. Okay, so there is really no contact between the adhesive to the mosaic per se. All right. So for prevention, if you have to use this type of backnetted mosaics, maybe for dry area it's still okay, yeah? Meaning internal wall that's dry. But if you have to use it in the area that has, is full of water like a swimming pool, and if water were to get in, it may just debond because some of this glue is water dispersible glue. All right. So if the water gets in and the mosaics fall off from the net, again, same thing, the adhesive is behind the net. All right. So it's something that's very difficult to manage. So prevention is possible. Do not use backnetted mosaics, especially in swimming pools. Okay, dry areas maybe not so bad, because you do not want the water to dissolve the glue. But if you really, really have to, then maybe instead of using a cementitious adhesive, then we will use an epoxy adhesive to bond the net and the mosaic uh, in those areas. Okay, but still, there's no guarantee because if the mosaic comes off from the net, it is still from the net supplier or rather from the mosaic supplier that comes together with the net. Okay, so this is to highlight what are the potential problems. If you have selected a tile like this or a mosaic piece like this, then we have to manage the situation because uh, uh, you know many installations have shown that your mosaic can actually come off, okay, if water gets a chance to enter the installation. So this is also to show you the different type of nets. This one, look at this. Okay, this is quite similar to the swimming pool one. You see, there is no way that adhesive can penetrate through. Okay, likewise for this, some tiles, uh, the supplier, put it like a mosaic and then put it together to give you a pattern. But if you look at the netting, again, there's no way that adhesive can penetrate well. All right. And even if the adhesive penetrate well, there's depth between the net and the back of the towel. So the worker must really press in the towel to ensure that the adhesive can go through. Okay. But using cementitious adhesive sometimes is a bit difficult to penetrate through. So if you really have to do this, then maybe you have to use an epoxy adhesive. But of course, if you compare the cost of epoxy adhesive and cementitious, the epoxies will cost a lot more. Okay, but the reality is this: the adhesive has difficulty penetrating through a netted tile like this. Okay, and sometimes deboning can also occur because of the substrate. Okay, when substrates are not properly cured and prepared, it does not provide a sound and stable surface to receive a tile and stonework. Okay, so when situations like this, tile debonded, a lot of stress here, and when we remove the tiles, we actually see this bedding full of sand. So it's not firm, it's not hard. There's a lot of loose particles, so it's not a very sound surface. All right. Same thing for this. This is a driveway. You open up, the mortar is still wet, it's still soft, so it cannot support the weight of the vehicles. Likewise for this is a picture taken of a driveway. It's a commercial building, and then there's this driveway, and the stone granite is 30 mm thick. All right, they use a good adhesive to bond, but over time the stone debonded. All right, so it's okay. Repair the stone. All right. After repairing the stone, a few months later, it happened again. It's a very unusual situation. So what we did was, okay, we shall investigate further. Remove the stone, remove this layer of adhesive, and then we see what's below. And this is what we found. Okay, on the surface it looks hard, but actually when I use a wooden stick to try to just dig the surface, I was actually able to create a dent. All right, so which means the surface is not hard enough. It doesn't have the necessary or the appropriate compressive strength to support the weight of the vehicles going over. Okay, so it's important that substrates have got good compressive strength to support whatever loading. All right, so this same installation at the area that is only for pedestrians to walk, where the cars don't pass to that corner, it's still in it's still intact, still in good condition. But the same application, but in locations that is open to cars to move, drive up and down. Yeah, repeatedly with that movement, a lot of movement and the loading, and this substrate cannot support the weight. The stone just give way. All right, so they need to address this issue, substrate. All right, so take note, deboning can also occur when the substrate is not sound and stable. All right. So in your normal screed and render application, okay, it's important to allow curing to take place. So generally the guideline is 7 days for 10 thickness, all right? Because in this curing period, of course, you'll gain strength. Over time, the mortar will gain strength. And in this curing period, as the screeds go through the hardening process, uh, shrinkage may take place. You do not know us, but if shrinkage were to take place, it will take place during this period as the mortar dries out. And when that happens, it may produce sufficient compression forces to break the adhesion between the tile and the bedding mortar. Okay, so if you're using flexible adhesive that can take that stress better, then maybe it's no issue. But if you are using a rigid adhesive, okay, normally the cheaper range are the rigid ones. So if your screeds are going through some shrinkage and there's some stress, you may actually experience debonding. But of course, in the earlier slide, if that screed is to support a vehicular traffic in a driveway, then obviously the strength is not good enough to support your tile and stonework to, for the vehicles to drive over. All right. And besides the shrinkage and the hardening process, another thing that will take place, another situation will be your the water in the mortar bed will dry out. Okay, and as it dry out, it will achieve what we call a low percentage of residual moisture content. Okay, so generally when the screeds are wet, you can see it's wet. But as over time, you will see that the screed will dry out. And then normally when people do wood flooring, vinyl flooring, normally they'll check the moisture content. They say, okay, the screed is still wet, we cannot proceed. Okay. Likewise, when your screed is still wet, it is no good when you are installing your marble or your compressed marble, because when you install marble as well as compressed marble, the moisture content in your screed and your mortar bed has to be low. All right, so this is a very important characteristic that you need to observe when you're doing marble work as well as compressed marble installations, because the moisture is one of the triggers for your marble problems. So of course they say, oh, I don't have time, to wait for 7 days, 10 thickness, because 20 is 14 days. Okay, if you're doing remodeling work, upgrading, and if you have issue with time, then speak to us. MAPE has a rapid drying screed binder called Caption Pronto, whereby the moisture content after 24 hours is less than 3.5%. We can proceed to install tile, and after 2 days, we can proceed to install marble, natural marble as well as compressed marble. Okay, compressive strength after 1 day is decent. After 7 days is 22 Newton per mm square. It's actually quite good already. All right, 28 days we're talking about 30 Newton per mm square. It's a semi-dry bed, semi-dry screed binder, minimum 10 thickness. Okay, so if you have time issues, go for this. And if you want to install vinyl flooring, wood flooring, 4 days. Okay, after 4 days, the moisture content is less than 2%. Okay, if you're using the normal cement mortar screed, it's fine. Just allow time for curing to take place before you proceed with your normal tile and stoneworks. Okay. Okay, sometimes yeah, deboning can be due to latents. Also, another problem from weak substrates. Okay, latents. You can see this picture, this gray material, right? Yeah, these mosaics were installed using white adhesive, but I see a lot of gray spots on the back. All right. Actually, these gray spots are from the latents. Okay. So what actually could have happened is that the worker was trying to clean away the dust on the floor. But when he uses water to clean the floor, he doesn't take a cloth or a sponge to wipe away that dirty water. So the dirty water is left on the floor to dry out, and that becomes your layer of latents. Okay. So very important is use a damp sponge to clean the dirt on the surface. Okay. Sweeping the dirt on the floor is not good enough. You need to physically remove that dirt. You physically remove that dirty water that's present so that that layer does not harden to become your latents. Okay, because if that's your latents, then that is always the weakest point in your tile installation. So again, substrate. So substrate is very important, something that you don't see, because when you finish your tile work, you don't see the substrate, but that is your uh, baseline. Okay, if that substrate is weak, there goes your entire tile and stonework. Okay, so conditions for your substrate, generally we are looking for integrity, so no cracks or detached areas. So if there are any cracks, they should correct the crack or repair before they proceed. Then mechanical strength, yeah, must be strong enough. That's where we're talking about the hardening, gaining of the strength, compression strength is important. Okay, curing, dimensional stable. You don't want the mortar to be warping, so it must be stable. Compactness. Okay, so in all street material, make sure it's well compacted. Okay, there must be no areas with differing mechanical characteristics. Okay, drying, residual moisture content, okay, depending on the tile, your finishes, if it's a tile finish, marble finish, vinyl finish, wood finish, the moisture content varies, okay, but still you want to retrieve a low percentage of moisture content before you proceed with the work, okay, and the substrate must be clean, okay, must be complete absence of polluting substances, dirt, contaminant, etc. Flatness and plumpness, the other sides we see where your tiles, when they try to apply the adhesive, they're not pressing it in until it's compacted. Reason being substrate, they're trying to catch the final alignment. And generally that situation stems up from your substrate flatness. So generally before you proceed with the tile work, they need to do the setting out, and from there they need to check out what is your substrate tolerance. Is it within the accuracy? If it's not within the accuracy, they should try to correct it first before they proceed with the tile work. All right, and then sometimes some issues if you have selected agglomerate stones. We have natural stones, we have agglomerate stones, artificial stones, engineered stones, as long as man-made stones. Okay, these man-made stones sometimes they're using natural marble chips, but it's binded with some binders. Okay, generally polyester resins, and they're supplied thin, say 12 mm thickness, 15 mm. So we consider them quite thin as compared to natural stone, which is 20 mm, 25 mm, 30 mm thick. All right. And the interesting thing about agglomerates of this thickness is that some of these stones, they warp. If they warp during the first 24 hours of installation, then the key to this to overcome this warpage is to select the adhesive that's appropriate to what we call the dimensional class of the stone. And for this, there is a European standard a test method to determine the dimensional stability of the stone. So it is found in EN 14617, whereby they have this machine, and we have this plate and the sensors. So we test the stone, okay, to see that in that period of time, what is the stone's behavior, okay. So generally, such stones, they do warp when in contact with water, okay. And where is this water found? It's found normally in your cement-based products, okay. Whether it's one component adhesive mixed with water, two component powder and latex, yeah. So your stones are bonded over the surface with this thin layer of adhesive, which has water content. Okay, so some of these stones they react with the water. All right, so from this test, we will be able to group them A, B, or C, depending on the readings that we achieved or we obtained during this test. Okay, so for group A, we say they're quite stable. You can use a lot of adhesive products, normal settings, so you have a wider choice. But if the stones come under B, we will have to use a fast setting. If the stone comes under C, where in the first 6 hours the distortion is quite a lot, then we have to use what we call the type R adhesives. No cement, no water. Typically, this will be the epoxy adhesives and the polyurethanes. Okay, solve the problem, but very expensive. All right. So this test helps you to group the stones A, B, C. Okay, and from the data collected from the test, they're able to see whether it's less than 0.3 mm deformation, or between 0.3 to 0.6, then we say we use fast set. Or if it's C, where in the first 6 hours the distortion is very high, such that the cement-based products cannot deal with the stone, then you have to use what we call the reaction resin. Okay, so the test doesn't have a pass or fail. The test basically helps you to collect the data to group the stone A, B, or C. Stable, sensitive, or very sensitive, unstable. Okay. So of course, under ABC, then we will have products for this category. Okay. So we say for class A, you can use the normal setting. If you're on a fast track, you can use fast setting. Okay. But if the stones are class B, then we say no, you cannot use the normal setting. Okay. The only if you have to use a cement base, it has to be the fast setting series. Then for group C, neither normal setting for fast setting. As long as cement base, you can't use the product. But for type C stones, you have to use the PU or the epoxies. Okay. So generally, we can do the test for you. Otherwise, some of the external labs can also do the test for you. So that is to handle the stone from warping during installation in the first 24 hours, selecting the adhesive that is appropriate to the stone type or the stone behavior. But there are situations where you encounter warpage, okay, after installation where the floor is already in service, and generally this happens maybe 9 months later, 1 year later, 2 years later, okay. So when it happens so much later, what could have happened, you know? So when we have situations like this, normally you will see characteristics like humping, you know, like the stone has bulged. The stone has a little bit of a hump, okay? Yeah. And when you have this hump, it also is accompanied by cracks. You will see cracks either at the joints or cracks within the stone. And for the stones to behave this way, whether it's warped or cracked after the floor is already in service, the two likely situations that has caused this to happen is expansion of the stone, because these stones are using polyester resins. Yeah. So sometimes presence of humidity or presence of thermal stress or heat. Okay, the stones can have this expansion. All right. And if your joints are too narrow, you don't allow that space for the stone to move. So when the two stones come together, you know, it will just cause a stress. And then when it's too much for it, now it will just bulge out. Okay, so that's why you can see the hump. All right. And it's more severe, you actually see the cracks. Okay. Or it could be shrinkage in the substrate, such that the stone doesn't fit into the space anymore. So if the stone doesn't fit into the space anymore, your stone butting against the other stone is, you know, compressing. So it's similar to the buckling concept, where it's the tension being pushed together. Yeah. So situation like this, you see cracks. Okay, so allow a wider joint. All right, you want to allow that space for the stone to be able to move and come back. All right, but of course, using a flexible adhesive is important. But the point is that for agglomerate stones, when you have that situation, one of the key solution will be to provide also a wider wider joint. Okay, you can actually see the lip and the crack. And when you remove the stones, you can see the stones no longer flat. So this one is a result of the hump. Okay, when the stones push against one another, you actually see the hump. That's why you can see that this part is no longer flat. Okay, so allow a wider joint. So if you're selecting agglomerate stones for your installation, yeah, do consider a wider joint. But sometimes these stones, of course, they're cut stones, yeah, but sometimes the cutting size may not be accurate. So if your joint is only 1.5, sometimes the stones come, especially when the stones are very large pieces, okay, and the cutting precision is not there, you might end up some stone joints totally no joints because of the space taken up by the cutting inaccuracy. Okay, so allow a wider gap. And restraint surfaces, okay, if you have a last piece butting against the aluminum frame of a sliding door or anything that's restrained, like maybe the last piece against the wall, okay, insert a movement joint or a sealant joint, okay, perimeter joint that gives you that uh, what you call that ability to absorb any expansion, okay. So restraint surfaces, put a sealant joint, okay. Then for natural marble, okay, for agglomerates, very seldom you have moisture marks issues. Moisture marks is normally because the stone is absorbent. Okay, so if you're using natural stones, you may have situations where you install the stone and then you say, hey, my stone hasn't dried out and I see all these patches. Okay, it's actually watermarks. But the watermarks may not be permanent. If the stone is allowed to dry out in a well-ventilated environment, your stones may just come back to the same color, all right? Which it will, but the condition is it must be well ventilated. For this project, the installation was done in the basement where the ventilation is very, very bad, very poor, very humid, okay? And for weeks, the stone just don't dry out. That's very bad ventilation. So in this kind of situation, our solution is to use fast setting materials. Okay, you see the finishing in the stone, okay, much nicer. Because when we use fast setting adhesives, it has got rapid hydration property that can address the issue of moisture marks. okay, in the stone, because it speeds up the drying process basically. All right. So for options, when you have washer marks in stones, instead of a single component normal setting adhesive, generally we choose a two component powder and latex. Less water in the mix, okay? And normally two component products has got better water retentivity, okay? But sometimes it's still not good enough because it's normal dry. It takes time to dry out the moisture, all right? And that's where we say a better choice will be a fast setting product. Okay, fast setting can be one component, can be two components, but because of the rapid hydration property that is in the fast setting adhesive product, it speeds up the drying, so your stones will dry much faster, then you have less issues with your moisture marks. Okay, but of course, if the none of the above solves your problem, you still have a backup, which is the R. When there's no water in the mix, you normally don't have an issue with the moisture marks. Okay, but of course, we discount the moisture mark from your screen because we already say your screen has to be cured. All right. But normally, when we have moisture issues, the choice of a fast setting normally will solve your problem. Okay, but of course, you can do a trial, you can do a mock-up to see your finishes, whether it's acceptable and it meets your expectation. Okay, most of the time, our experience shows that the fast setting will more or less do the job for you. Of course, sometimes you say that, okay, then I will put a sealer on the back of the stone. Okay, for us, that's not your solution because it doesn't solve the problem. Okay, things can still go wrong. All right, the stone's porosity is not uniform. Yeah, we know natural stones, the capillary, the pores in the stone or yeah, the spaces, intercrystalline spaces in the stone is not homogeneous. Okay, so it's not uniform. Then if the worker try to apply the sealer, it may not be thoroughly sealed. Some parts too much, some parts too little. Okay, and the worry is that some parts too much, you may actually end up with residue, which is a problem again. Yeah, or sometimes it could be the residue moisture from the street. Okay, so these are also issues pertaining to your moisture marks. All right, so sealer is not the solution. All right, solution will be number one, your cement mortar bed. Okay, your street mortar has to cure and dry out fully. Okay, until you achieve a low percentage of the Russian moisture content. Okay, thereafter, between the normal set adhesive versus the fast set, choose a fast set adhesive. All right, as we say, the fast set has got rapid hydration. The moisture dries out faster. Your stone also dry out faster. Okay. Then if you really want to use a normal setting, then use the two component. But generally, our advice is use a fast setting. But still, we can do a mock-up. If you have a very good ventilated area, the normal setting two component might do the job for you. Okay, but if in areas where you want to speed up, for example, say there's some condominium projects, they install the marble in the living room, and 3 days later they want to cover with protection. Okay, the stone cannot breathe after that. That kind of situation, you might have to use some fast set material. Okay, so it varies according to your site situation, your expectation, and your provision for the stone to dry out. So some mention about the stone sealer. By right now, these stone sealer products, they are not meant to be applied on the back of the stone. The original intent is actually the surface. Okay, surface of the stone. Why? It is to protect the stone surface from spillage. Okay, if you have a marble floor in your living room, a hotel lobby, and somebody spills coffee, somebody spills Coca-Cola on the floor, you want to prevent that from staining your marble, and that's where this stone sealer comes in. You're supposed to apply the stone sealer such that it gives you that repellent characteristic to repel the water from absorbing into the stone. Okay, eventually it will still absorb. All right, it is not a protective membrane per se. All right, when you have a spillage, it gives you enough time to come back with a cloth and clean it away. Okay, if you don't, and you allow that spillage to stay on top of the stone surface, after a few hours, that spillage can still penetrate in and can still cause a ring. Okay, so can you imagine if this is a situation on the back, it's the same. So when your stone is sitting on the adhesive, it will still penetrate through eventually. All right, so sealing on the back is not the answer. But as I say, sealer products are meant to protect the stone surface. But take note, stone sealers, they are the water-based sealers and the solvent-based. Okay, of course, now everybody's going eco, then people will choose the water-based. But even then, regardless, water-based, they are the water-based sealers that are water repellent and the water-based sealers that are water and oil repellent. What's the difference? Water repellent means it only repels water-based products. So if you spill water, it will repel the water. If you have a water and oil repellent sealer, it will also repel oil-based products. Okay, if you use a water repellent and you spill some oil-based product, it may not repel well. Your stain can still penetrate. All right. So a better choice on the surface is always a water and oil repellent to be more effective. But of course, this range will be a bit more expensive than the water repellent. So there is this. And for sure, we will never want to use water and oil repellent on the base. It's very good for the surface, but not on the base. Okay, it may compromise with the grip, the adhesion. Okay, but nevertheless, as I said, we discourage applying on the back. The original intent of impregnates primarily is to protect the stone surface caused by the spillage. Okay, and these sealers, they are formulated such that they allow the transmission of vapor, which maintains the breathability of the stone. So a lot of these stone sealers are breathable. After applying the sealer on the stone surface, the stone is still allowed to, it's still able to breathe because it's a breathable sealers. Okay, it doesn't close up the pores. Okay, so it can still breathe. It's a breathable sealer. It repels water from absorbing into the stone surface, but whatever moisture is able to breathe. Okay, but eventually whatever sits on the surface, it will still go in if you do not wipe away the spillage. Okay, it only slows down the reaction of that spillage from penetrating in. Okay, so you have to take a cloth and just clean away the spillage to prevent that stain. Okay. So the worry is that sometimes when the stones come with sealer on the back, you may have this kind of situation, yeah. Uh, when you have this water repellency on the surface, it's very good. Yeah, it repels the water, so you have external flow with this kind of sealer protection, very good. When it rains and your stone is not wet, will not be so wet because it doesn't penetrate so easily. But if you have this surface on the back of the stone, you look at this beading, the grip is no good with the adhesive. Your adhesive cannot grip. It repels the water. All right, so the grip is no good. Okay, so generally, just take note, when we want the stone with the adhesive to the substrate, we want to have a good mechanical grip. So sealer products like this is what we call the interfering layer. Okay, it impedes the adhesion. It doesn't give you a good bond, and yeah, compromising the adhesion. Okay, so we prevent that. So as I say again, if your concern is washing marks, the route that we go is to choose a fast-setting cementitious adhesive product. Then we also have issues like efflorescence. Some applications you have efflorescence, and say, how to solve this problem? Okay, a question is where does it come from? Okay, so we have installations all over the world. This is in Italy. We see efflorescence. This is Singapore. Even from a plaster wall surface. Okay, there's no tile surface. This is plaster. All right. And then we have all the different applications, yeah. Korea, blah, 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 Japan. And this one is pebble wash. You also have efflorescence, okay? Yeah, so where does it come from? It's actually a natural occurrence, all right, when water has traveled through a water path to meet with the salt in the Portland cement mortar. So what are the Portland cement mortar products? Your screed mortar, your render mortar, even your cement-based adhesive, regardless of brand. Brand A, brand B, brand C, as long as it's Portland cement-based adhesive, the salt is there, all right? But by itself, it doesn't become efflorescence. It has to be a combination of these three. The salt that's present, the water entering the installation through a water path. Okay, so the water must meet the salt in order to become the efflorescence. Then it's being drawn up to the surface. Then the water dries up, evaporates, and the salt remains on the surface, and that's where your efflorescence comes from. Okay, it's crystallized salt, right? So as we say, the three must come together for it to happen. So what we need to do is to make sure the three don't come together, and for that to happen, is you need to eliminate one of them. All right. So a situation like this, a site condition, this is external. Okay, there's no shelter when the workers did the application. So they proceeded to do the vertical pieces, but the coping is still open. All right, so exposed to the rain, and they left this for weeks. They never closed up the coping. So water has already entered the installation, and you see all the fluorescence. Okay, so you need to block the water path. Make sure water don't have a chance to enter to meet the salt. All right, so generally think of where the potential water path is and block that path. Make sure water don't go in. So for external tiling, whether it's E-deck, external floor, you see the tiling on the floor, okay? And then when you do tiling, generally you will fill the joints after 24 hours, okay? If you're using normal set. If you're using fast set adhesive, maybe 4 hours. But normally you'll be using a normal set adhesive, and to be able to step onto the floor, it's normally after 24 hours, so the workers can come back to fill the joints. So can you imagine if you do the installation in the day and the night it rains, cats and dogs and water, just enter through the joints, it will meet your cement mortar already. Okay, so those are also avenues for water to enter to meet the salt in your cement based products. So ideally, you provide shelter. Otherwise, you have to find a way to protect the installation from water entering the installation. Then sometimes you have, joints are very narrow. So the earlier slide we say, no butt joints, okay? You cannot fill the joint. You look at this, very hard to put the mortar into the joint. So in situations like this, the grout will come off and then water will get in, okay? So prevention, of course, as we say, make sure water don't go in. But sometimes in fixture wall, very hard to, take care of too many things. So what we have is a suggestion. Yeah, if you have a fixture wall and there's a lot of cement mortar here, okay, it's shown in the yellow zone. Regardless of brand, Mape we have Nivo Plan, but even if you use other pre-pack, it's just cement mortar. All right. So what we do is we let this layer cure first, then we apply a waterproof membrane like Mepalastic over this layer to protect the salt or to block the salt from this layer, so that if the water comes in and if it meets the salt, it only need a thin layer of adhesive here. Okay, so we have a layer of Mepalastic to protect, and then the thin layer of adhesive, then your choice comes in. Okay, if you choose 100% Portland cement based adhesive in the normal setting range, then of course 100% salt is there from that layer. Then of course, if you choose fast setting products like Granny Rapid, Cara Quick, Elasto Rapid, a lot of the fast set cement and very low content of the Portland cement, then the salt content is also lesser. So if it should happen, maybe it's a bit lesser than most of fluorescent situations. Or if you want, use Carapoxy. This is the epoxy material, no cement. If there's no cement, there's no salt. Okay, so it's a matter of how you want to do your selection. But take care, when you have a vertical application and a coping, the detail here, by right, this one should be a sealant joint. Okay, sometimes we see a lot of detailing, they will have a very narrow gap here and they try to fill with grout, tile grout, and it breaks off very easily and then water gets in. Okay, so if we were to look at some guidelines, this is by the Tile Council America Handbook. For this detailing, it's a soft joint, flexible sealant, okay, so that it's able to cater for any movement expansion, and then prevent the area from cracking up. Yeah, then water don't go in through the joint. So sometimes your detailing does play a part. All right, so specifying selecting the right adhesive with the relevant properties is required for your tile and stone work. If you have a big stone on the wall, then choose a product that has got the required strength, the required property. If you have a sensitive stone or other stone that has got measure marks, then choose a stone that's choose an adhesive that's fast setting property. Or you have agglomerate stones, then we have choose a product that's appropriate to the dimensional class. Okay, so for selection of adhesives, we can refer to the standards, and the standards will be the European norm 12004, which is also the British Standard European norm, and then we have the ISO standard now 13007. So there's a summary of the standards. We have normal, what we call it C1, C2, in relation to the bond strength. So these are the fundamental requirements, because all adhesive must have fundamental requirement of adhesion strength. Okay, C1 is normal performance, C2 is improved. And you can see from the slide here, improved meaning all C2 products, the minimum tensile adhesion strength is equal or greater than 1 Newton per mm square, based on the test method spelled out in the standards. Okay, so for Mape, we have products that are 1.5 Newton per mm square, 1.8 Newton per mm square, 2.5 Newton per mm square. So the bigger the stone, normally we factor a stronger material. Okay, then of course we have open time 20 minutes. Then fast setting, early strength. Okay, obviously fast set open time is shorter. Then T is for no vertical slip. We are doing vertical application. It's good to have this property. But otherwise, you can still use a spacer in between your tiles and your stone. Okay, extended open time is important if you're working with larger tiles. Yeah, we talk about, remember, the open time. If the tiler does not cover the adhesive with the tile within the open time period, skinning may occur. So if you're tiling over a bigger area, choose the property of extended open time in the product. S1, S2 will be deformable adhesives, flexible. So if you're doing with installations that subject to stress, differential movement, subject to vibration, you might factor this property in the product selection. So if you refer to the standards, they have all these properties, then sometimes you have to see what property you need for the installation. So I'll give some examples. So for example, you say, okay, I have a marble on the wall. What's the property I need? Then we say C2, okay? Minimum strength of 1 Newton per mm square. All right, if it's bigger size, of course, we will factor in a stronger material. Then if your stone is sensitive to the moisture, then we will say choose a facet. So it will be C2F facet, okay? Then if you are installing agglomerate stones and you know that this stone is at the class B, then you want a C2 facet. So it's C2F, right? Then if it's a deformable substrate, say you're tiling onto a drywall, tiling onto driveway, where you know you're going to subject to shear stress, vibration, impact, then you want to have that property of S1 or S2, then we have C2 S1. Or if it's a facet, it's C2 F S1. Okay, so you add on. It's an add-on. Your C1, C2 is your baseline, and you add on the properties according to your installation. Okay, then if you are doing glazed ceramic tiles subject to tile crazing or crazing lines on the tile, the surface of the glaze, normally we will use a two-component S1 product. Okay, then for larger tiles, extended open tie. If it's ALC, AAC substrate, a medium flexible adhesive. Okay, if you're bonding onto concrete, onto render, those are more sound. So depending, if you're external, then of course we want to have S1, S2. But if you're internal, normal concrete wall, the flexibility is not critical per se. But if you're bonding onto ALC, AAC substrates, then we normally recommend a flexible material or a medium flexible at least. Yeah, thermal variation, S1, S2, especially external works, differential movement, S1, S2, then if you have a fast turnaround, then facet. Okay, so you plug all these properties and then you say, okay, this product, for example, Mapei Granny Rapid is C2FS1. So if you want C2, you want a facet, you want a flexible, it can be found in Granny Rapid. Okay, so stick with Mapei. When you have an installation, I'm sure Mapei will have a solution for you, and products can be recommended according to your requirements. Okay. Thank you for your time, and now is the time open for questions. Thank you.
Thank you very much. Thank you very much, Jess, for the interesting session. Today, I also have another person that will be a backup, is Alison Bong, who is a product manager for ceramic and stones for Mapei Malaysia. She will be here to attempt questions as directing to Malaysia specialty, right? I have a few questions here that's posted by our audience. The question is for Jess. First one, will dark color tiles or shade will have higher thermal variation and cause higher probability of pop-up?
Okay, good question. So referring back to my earlier slides, if you are expecting expansion because of thermal variation, a few things will be flexible adhesive, bigger joint width. Okay, so if you are selecting a tile that is dark colored, chances are it will absorb more heat. So with that consideration, you might want to give more provision. Okay, so you have to anticipate, dark colored generally will absorb more heat. It is a fact. Yeah, so you stick on to the rule of thumb. If you're experiencing expansion, thermal variation, then flexible adhesive, wider joints, and if it's a big tiling span, movement joint. So if you are, like I said, if you're selecting a dark colored stone or tile, and the chance of expansion is going to be even more severe than the normal light colored ones, then your provision should be even more. Yeah, so you would say a higher safety margin.
Okay. Well, I hope that answered the questions to the person who asked this. The second question is also to you, Jess. If the tiles with netting is a problem, how do you rectify the issues in the event we cannot remove the netting?
Okay. It's difficult because first of all, mosaics being smaller pieces, they're normally put together. Okay, so that's why we say face paper mounted. Yeah, if at all possible, use a face paper mounted. In some of the slides I've shown you some pictures, some examples, okay, of mosaics with backnetting. So you need to see the backnetting because the ones I showed you, the netting it comes in such a pattern that it is quite difficult for the adhesive to penetrate through. Okay, but of course I've seen some mosaics with just thinner netting. You just have to see the condition of the netting because you need to be comfortable that the adhesive can penetrate through the net. Okay, that's one. Number two, if this backnetted mosaic is used in a dry area, the chance of the mosaic falling off from the net is lower because you don't have water to disperse the mosaic from the glue per se. Yeah. Then if you want to play safe again, then we will say use an epoxy adhesive or polyurethane adhesive. We cut down the water in the base product. Okay, so it varies case to case. So we will try to give you solutions to cut down the problem, to minimize the problem. So if you're using a backnetted mosaic, if you're using for dry area, then choose an adhesive that can help to penetrate through the net for good contact. But if you're using a backnetted mosaic for a swimming pool, the chance of a failure or the mosaic coming off is quite high. Yeah.
Okay. The next question is actually directed to Alison. What is the common issues of defect that you have experienced in Malaysia?
Okay, the most common, usually hollowness they found, because a lot of developer, then house owner checking, they need 100% no hollowness. But because of most of the site that we've been, most of the shield wall was out of alignment. So the tiler tend to use adhesive, battling with a very big notch, So they don't really compress it well. So mostly on the edges and the spot, on the spot. So a lot of the developer will come to us, what do you accept? It's not for us to accept. It depends whether they want to accept 100% or 80%. So most of the issue in Malaysia tiling industry is the hollowness. So I don't blame the tiler because they really need the thicker bed, they use the back battling. Our technical team ask them to use trowel, but they can't do it. They need to do the surface preparation, but most of them come to do the tiling work without doing the surface preparation. That is the most common issue.
Okay. Now then it will ties into our next question, which is directed to Jess. This question is like this. As hollowness can be a quite common defect, how do you determine the percentage of hollowness and how many % can be considered as defect?
Okay, let me try to break down the question.
Yeah.
Okay, hollowness as a common defect, sometimes when the inspector or the officer say, oh, this is hollow. So, as we've seen in some of the slides, some hollowness is because of air voids. Okay, some hollowness, like for example, the buttering method, okay, where the adhesive is not touching the substrate, obviously it's hollow. So it's difficult to indicate some hollowness, whether it's okay or not okay. All right. As to how much, what percentage, it depends. For example, if it's just air void, like the tower method, air voids, it really depends on how stringent the QA or whatever project expectation is put.
Yeah.
For example, say in Singapore, if they're subject to a BCA inspection, the percentage you see, we're talking about 91% contact. That means the percentage hollowness is very low. But of course, to be 100% in contact, it's not realistic. But you see, from a tiling point of view, if the tile is well beaded and there's some hollow spots, say if it's 80% bonded, well bonded, the chance of that tile falling off is actually very low. Okay, but if it's hollowness because the contact is weak, then the chances of debonding can be there. So the hollowness, it's a different scenario. Okay, if it's air void, but generally the contact is good, actually the installation should be quite sound. But if it's hollowness because the adhesive, the one that I showed the slide where there are 2 layers of adhesive, and the stone never pressed in, okay, that could also be hollow, and that could be weak because your stone is hanging onto the inner layer of the trowel rib, okay, and that part is the weakest link. So that hollowness, so unless if you experience situation hollowness, you might need to break open or cut open one to see what's the inside to determine. Like for example, say there is this marble floor that I came across. Because of the backnetting, they remove the net, then there's this glue, okay. After the installation, everything very nice, no problem. But after polishing, hollowness, okay, because with the polishing, the weight of the machine and the stress caused that hollowness in the marble. But the contractor had difficulty trying to hack out the stone, what I mean? It's hollow, but he has to literally hack out. So the bonding is still good, but it's hollow. So there are different types of hollowness. So I cannot make one strict statement that hollowness is okay. It really depends case to case. So it needs to be investigated. You need to verify whether that hollowness is acoustic or the hollowness is because of some parts because of the glue in the marble, or it's because it's not well bonded. If it's not well bonded, obviously that's not acceptable lah. So it varies. It varies.
Yeah.
I see. Wow. So that means technical know-how, experiences that you have in MAPE will really help, right, to determine all this.
Okay, sometimes students, for example, if you refer back to the slide where I show you the stone that came off, you see the 2 layers of adhesive. If you remember the rule of thumb, the 2 layer must not remain 2 layer. It must be well compacted. Okay, so if you have hollowness and you open up the tile or the stone and you see the 2 layer, you know the installation is relatively weak. So you ask me can last for how long? It depends, because I do not know how much the worker press in. If he press in a little bit better, may last longer. If he doesn't press in that too well, it may not last that long. So it's a question mark. But if you open up, you see that's a clue already. So generally, after 1 or 2 times you see this, you roughly can tell. But as I say, just remember the rule of thumb in adhesive application. Thicker does not mean better. Okay, what we want to see is a thin, compacted layer that is able to have a good grip.
Okay, thank you very much. There's last questions here, also to you, Jess. Okay, you say other than C1 and C2 cement adhesive, is there any C0 or C3 available?
Okay,
Can we get it in
right. As now in one of the slides, I showed you a summary, right? C1 and C2, these are the basics, fundamental. Okay. In fact, adhesives in the standards, there are 3 types: cement base. So C represents cement base. D represents dispersion base. So all the paste adhesives come under D, so there's no cement. Then the R, type R. So R will be all the epoxies and all the polyurethane. We say reaction resin, whereby the hardening process of these adhesives are by chemical reaction. So we have C1, C2, cementitious class 1, which is the normal performance. This is your basic product. Then we have cementitious class 2. Okay. Then we have dispersion D1, D2, R, reaction resin, R1, R2. 2 classes, class 1, class 2. In adhesives, in accordance to the standards of the European norm and the ISO, is class 1, class 2. No class 0, no class 3.
Okay, that's very clear. Okay, that's about it for the questions for today. And if you have further inquiries or further questions, please do contact MAPE Malaysia at mape.com.my. Or you can call us at 7842-9098. So before I pass the time to Lillian, On behalf of MAPE, I would like to thank all of you for tune in into this channel, and I would also like to give away. Remember this mask? We are giving away 10 of this mask, and the winners has already been identified. So I will pass the announcement of the winners to Lillian. Back to you, Lillian.
Thank you, Cynthia and Alison, and thank you so much, Jesseline. I trust the session was wonderful, and I learned a lot of things. Now, ladies and gentlemen, as mentioned by Cynthia, MAPE is giving away 10 sets of 3-ply washable masks to 10 winners. I have the winners on hand, so if you are still tuning in, you will hear me announce your name. From 2 different platforms. The first platform is the Archidex online platform. I have James, Crystal, and Adibah B. James, Crystal, and Adibah B. And I have winners from the Facebook platform. That they are Elaine Teo, Yuki Wong, Liu Pei Hong, Catherine Ui, YL Xiao, Jacinta Yi Q Ing, and Syed Ismail. Now we're gonna put the winners' names in the comment section. What if your name is there? Please contact us from Facebook. Just come to Archidex Facebook and PM us, and then we will teach you. We'll let you know how to redeem those those masks. So thank you so much. Thank you so much once again, MAPE, for doing this with us. With that, ladies and gentlemen, this marks the end of our today's session. Thank you so much once again to MAPE, Jesseline, Cynthia, and Alison for being here with us today. To the participants, we would like for you to do a quick and short survey to let us know how you think of our Archidex Fast Forward webinar series. We will send you the link in the comment section again. Thank you and see you soon. Goodbye.
Bye-bye.
Thank you.
Bye. Thank
Bye.
you.
Thank you.